Okay. Okay, let's start the first question. So in the first question, given that what is given that first of all there is a disk, na? There is a disk, and the disk it moment of inertia. Given that what is the formula for moment of inertia? The disk the here the axis passing through center of the disk and perpendicular to the plane. That means moment of inertia of the this disk I equal to m r square by
R
2.
square by 2.
Okay. Oh, very good. Next, and um, he said that after this is rotating with the angular velocity that means omega 1, and also then he said that in the question one other disk also placed on this disk. Um, what about what about the mass? Okay.
Mass M radius R.
Okay. So another mass of m by 8, na? So that is m by 8. M by 8. And what about moment? This one moment of inertia. Even. What about moment of inertia I2? I2. Whenever the mass added to the first body, then moment of inertia by using parallax theorem, you can find out na? That is
Yes.
I naught plus m r square. That means I naught is nothing but disk. That is m r square by 2. So here okay, m r square by 2. And what about mass given that plus 1 by 2? Mass of the object m by 8. M by 8 r square. Okay, finally you get that moment of inertia of I2. Moment of inertia I2 5 by 8 m r square. If you solve this one, you can get 5 by 8 m r square. Now we have to find the omega 2. Omega 2 we have to find out. How can you find omega 2? By using conservation of angular momentum. That is L1 equal to L2. That means I1 omega 1 equal to I2 omega 2. This equation you have to use. And what about I1? I1 is the moment of inertia of the disk first. That is mr square by 2. And what about omega 1 omega? Let's take omega. I2 5 by 8 mr square. And this is omega 2. Now omega 2 you have to find it. Mr square cancel here. 2 1s are 2 4s are. That means you can get here 4 omega by 5. Sorry. 4 omega by 5. Uh, that is omega 2. Okay, you understood, right? Omega 2.
Yes.
Okay.
Yes, sir.
Very good. Next, go with the second question. Okay. Okay, next question. I think question number. We can solve this question. Okay. So next question. In the question given that. Okay. Okay. Flywheel is in the form of uniform circular disc of radius 1 meter and mass 2 kg. Okay. The work which must be done on it to increase frequency of rotation from 5 rps to 10 rps. That means a revolution per second. Okay. So what is the given in the question? What are uh, the given a flywheel in the form of uniform circular disc, and radius is 1 meter. Na? Radius is 1 meter. Next, and mass 2 kg. That mass is 2 kg. And omega 1, that is angular frequency, 5 rps. 5 rps, omega 2, 10 rps. Now, you have to find the work done. What is the formula for work done? Work done equal to work done. Work done equal to, already we discussed that in rotational motion, work done equal to change in kinetic energy. That is 1 by 2 m. That means 1 by 2 I omega 1 square minus 1 by 2 I omega 2 square. This is the formula. You can common here 1 by 2 I omega 1 square minus omega 2 square. How can you find the I? I is the moment of inertia. Na?
Yes.
Moment of inertia I equal to what is the given? Which one?
Um, Disk.
Disk.
Circular disk.
Disk
Yes.
moment of inertia
mr
mass
square
square
by
by
2.
2. So
2.
m value 2. What about r square 1 square? Okay, and also okay, this is 2. Now 2 to cancel 1. Moment of inertia you get 1. Na?
1. Yes.
Oh,
Yes, sir.
okay. So now that means 1 by 2 moment of inertia 1 and omega 1 given 5 rps.
Yes.
But
5
RPS,
by 2 given.
RPS is revolution per second. Revolution per
Yes.
second. That is the meaning of actual mean revolution. Okay, that we have to convert first one. So
Yes.
first of all, we can convert this one. Omega 1, 5
5.
RPS. That means
Yes.
5 revolution
5
per
pi
second.
by.
5 revolution per second. That is the meaning. 1 revolution is nothing but 2 pi radian. 2 pi
Yes.
2 pi
radian.
into
Radian
60.
per second. Now, what about this one? Omega 1? 5 to the 10 pi. 10 pi
10
radian per
radian
second. What
per
about
second.
omega 2?
Omega 2.
Omega 2 10 rps. 10 into
20.
very good, very good. 10 into 2 pi radian per second. That means 20 pi radian per second. We get that one. 20 pi. Now omega 1. Omega 1 means 10 pi. 10 pi square. 10 pi square. 10 pi
100.
square 100 pi square minus omega 2 square. Omega 2 20 square is nothing but 400. 400 pi
400.
square.
Yes.
Pi square. Okay. Now what is the okay? Now 1 by 2. This is 100 pi or 400 pi, na? Simply. So that means 300 pi square. That means here you can take here omega 2 square minus omega 1 square. That means here you can get
Yes.
400 pi square and here 100 pi
Yes.
square. Okay, minus you can neglect this one. So 300 pi square. 300 pi square you get here. So 300 by 2. Uh, you can solve this one. Okay. 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 What is the possible now? 300 by
150 pi square.
very good. 300 by 2 is
150
nothing but
pi square.
very good. 150 pi square is nothing but 10 approximately.
Yes.
Why? Because pi
Okay.
equal to 3.14 na. So that means pi
Yes.
square is nothing but 3 3s are 9. So 9 point something. You can take that one 10 approximately. You can get 150.
Yes.
Okay, around 1.5. Okay, you can get which option? 150. Okay, this one. Okay, 150 into 10. That means 1.5 into 10 power 3 can write na.
10 past 3.
Uh,
Yes.
so this is the answer. You understood, right?
Option C.
Yes,
Okay.
sir.
Anyone? Any
Yes,
doubts?
sir.
Any? Yeah. All are understood.
Yes, sir.
Okay.
Yes, sir.
Remaining. Okay. Okay. Go with the other question. That is question number third question. Okay. Okay. We'll start the question. Okay. In the question given that uh, okay, a particle of mass 5 grams. 5 grams. Given that 5 grams. What is the given data? That is nothing but mass. Mass 5 grams. Next. Is moving with the uniform speed. 3 root 2 in xy. Okay, 3 root 2. Given that uniform speed v equal to 3 root 2 centimeter per second. Okay, after that, in the xy plane, along the line y equal to 2 root 5. That is y equal to 2 root 5. Y equal to 2 root 5 centimeters. Actually given centimeters. Okay. Next. The magnitude of the angular momentum. We have to find the angular momentum. Okay. If the particle given moving uniform speed moving in a xy plane along line y equal to 2 root 5, the magnitude of the angular momentum we have to find it. Okay. So angular momentum means L. L you have to find L equal to mv/r. This one. Simply. Okay. Okay. All of you understood the question? All of you
Yes, sir.
understood the
Yes,
question?
sir.
Okay. Anyone any doubts? Any doubts?
No, sir.
No.
No. Okay.
No, sir.
Okay. Okay, we'll solve the question. Okay. Okay. Okay, given that there is a xy plane, okay, there is a xy plane. Let's take this one. The xy plane. Okay, in this xy plane, what happens? There is a particle moving. There is a particle moving along this direction. How it possible? Given that y equal to 2 here, y equal to 2 root 5 na. So that means this is the 2 root 5. This height is 2 root 5. 2 root 5. This is the particle moving. Here the particle moving. Next. So this is the okay. Next, what is given that mass is given that okay, v is given that okay. Now, what is the formula for angular momentum? Angular momentum L equal to mv.
MV square.
Not mv square na. MVR. R is perpendicular. Already we discussed now. What is the basic angular momentum? L equal to R cross P. That okay. Here R. What is P? P is nothing but MV.
MV.
Okay.
Yes.
Finally, you can write this one.
L is equal to MVR.
R cross V. R MRV sin theta. So okay.
Yes.
MV V perpendicular. R perpendicular here. So given that,
Yes.
what is mass?
Mass
5 grams. 5
grams.
grams.
Yes.
So 5 grams. So let's take you in. Okay, let's take options are in gram centimeter square. You can take like that grams in yes CJS unit 5. And what about velocity 3 root 2? And what is perpendicular distance? That is 2 root 5. Now, okay, we can get here. Okay, 5 2. Okay, what is the what we can get here? 5 3s are 15 50. Okay, 5 3s are 15 52 are 30. 2 root 2 into
Yes.
root 5 2 10 root 10 30
Yes.
root 10. Okay,
30 to 10.
okay, so this is the 30.
Option D, sir.
Very good. 30 root 10. What is the unit here? Gram centimeter square per second. Any doubts? You understood, right? All of you?
Yes, sir.
Okay.
Yes, sir.
Only 2 members attended. Huh?
3 members.
3 members. Okay.
Yes.
Okay. 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 Next question. We'll start the next question. Try to answer the question. Then we'll solve the question. Okay, 2 questions are 2 questions completed, na? 3 questions completed. This question completed. Okay, 3 questions completed. Okay. The 4th question. Okay. Okay, this is the good question actually. Very important also. You understood the question, all of you?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay, if you see the question, okay, there is a given torque and position vector and force. So what is the relation between torque, tau, position vector, r, and force?
Yes.
So what is the relation between these 3?
Tau is equal to R cross F.
That means r cross f. Okay. Very good. Here, these 3 are the perpendicular to each one. So that means these 3 are the perpendicular actually. For example, okay. For example, let's take this one. So this is the R. This is the R. This is the force. We applied the force. So this R and F are perpendicular. And also, let's take this is x direction and this is y direction. That means x it is the position vector along x direction. Force is along y direction. Torque along z direction. Like out of the plane. You understood, right?
Yes, sir.
That means here R, F, and tau. 3 are perpendicular to each other. Each one. Okay.
Yes, sir.
These three are the perpendicular to each other. Now, the question given that by seeing the options, what about r dot tau? Here r dot tau means this is the r vector, tau vector. R dot tau means this is the dot product. R tau cos theta. R tau cos theta. That is the meaning of dot product, na? But because the radius and the torque both are perpendicular, na? So theta equal to 90. Okay, you understood? Theta is 90. Why? Because theta is 90. These three are perpendicular to each other, na?
Yes.
Now r
Yes, sir.
r dot tau cos 0 cos 90 in the cos theta 90 cos 90 becomes 0, na? So this is 0. Okay, this is 0. And f dot tau and similarly f dot tau also 0, because this is dot product. Actually, this is the dot product. In the dot product we get cos theta. Dot product we get cos theta. You know the dot product. Let's take a bar, b bar, dot. That means a b cos theta, na? So AB are
Yes, sir.
perpendicular. If AB are perpendicular, that means theta, in the place of theta we can substitute 90 cos 90. So therefore AB cos 90 is 0. So this dot product is 0. So these two are 0 because of what? These three are perpendicular to each other. Okay, you understood, right?
Yes, sir.
Any doubts?
Yes, sir.
Okay.
No, sir.
Okay. So we'll go with the actually 4 questions complete, no? Fifth question. The fifth question. Okay. Okay. We'll start the question. Question number 5. In the what is the given in the question? A particle.
Mass
Uh,
2 kg.
okay, very good. So given that mass
Yes,
equal
2
to 2
kg.
kg. Next.
Position vector
Uh,
r cross I plus j cap.
I plus j. Next. Velocity vector is also given.
Velocity is given to
Uh,
y cap minus j plus k cap.
minus j plus k, na? Okay, plus k. Okay, that is correct. Plus k. This one. So you have mass and position vector and velocity. So what he's asking in the question? He's asking in the question angular momentum about z.
Angular momentum
So already we discussed that angular momentum
about
L,
z axis. Yes,
that is equal to m
mgr.
r cross p. Sorry, r cross v. Okay.
Yes,
Okay. In previous problem also we discussed that. So
yes,
L equal to
Yes,
m. What about m? M is nothing but 2 kg. R is nothing but I plus j cross like 2I minus j plus k. This one. This one. Let's take 2 also outside. So here 2 is there. Here is 2. 2 2s are 4.
yes,
You can write 4 I plus j cross I minus j plus k. You have to complete this cross product. So to complete this cross product, you can take like this I j k. So what about here in the place of I 1 j component 1? What about k component here? Here k
0.
component 0 0. What about here?
Yes,
The second one 1 minus 1
yes. Minus 1
1
plus 1.
1. Okay, this is okay. Now we have to calculate this one. So I into, can take into 1 minus 0 minus j. Density 1 minus 0 plus k. Plus k. In the place of plus k, minus 1, this one can get here. This is I minus j minus 2k. Okay.
Yes,
And
sir.
here also 4 is there, na? The question that 4. So that means 4. 4i minus j. If you multiply this one, 4i minus 4j,
Minus 8K.
8k we can get. He's asking magnitude actually. Okay, and also along z-axis. He's asking along z-axis. Along z-axis means,
Yes.
along z-axis means this one, na?
K, yes.
Yeah. What is the coefficient of k component? K component okay, k ka coefficient in the coefficient minus 8, na?
Minus 8K.
Yes, minus 8.
Yes, sir.
Minus 8 is the answer. You understood, right?
Option D.
Okay,
Yes.
good. Okay,
Option D.
Yes, sir.
okay. Okay, 5 questions are completed. Go with the 6th question.
Okay, sir.
Question number 6. Okay, question number. Okay. Okay, next question. Okay, that one solid sphere, na?
Yes.
Okay. Okay. Given that in the question 31, sorry, question number 6th one, one solid sphere is there. So one solid sphere is there, na? Let's take one solid sphere. One solid sphere. What is the let's take this the one solid sphere. He is asking what is the moment of inertia along the diameter for solid sphere? Along the diameter or any axis, you can take any axis. Same one. Na? What is the moment of
Yes.
inertia? Anyone?
M square by 2.
Not a disk, it is a solid sphere, no?
2 by 5 ml square.
Oh, very good, very good. Question number.
Yes.
Okay. Given that moment of inertia, this is A. Moment of inertia of A, 2 by 5 m r square. And what about B? Hollow sphere. Given that hollow sphere, na? Here B is the hollow
Yes.
sphere. Hollow sphere ka moment of inertia
2 by 3 ml square.
2 by 3 mr square. Okay.
Yes.
What is the meaning of moment of inertia actually? The meaning of the moment of inertia to resist the rotational motion. Rotational motion.
Yes.
Okay. Which one is greater here? Which one is greater here?
IB.
Okay. Moment of inertia of okay. I of okay. I of A, I of B. I of B is the greater than I of A. Okay. Okay.
Yes.
That is the answer, na? Actually. Which option?
Yes, sir.
Okay. That's correct. So directly he's asking formula. Very easy question. Next, question number 7. Okay. So in the question given that find the ratio of radius of gyration. In the question given that find the ratio of radius of gyration disk and ring of same radii at their tangential axis. Okay. Given the tangential axis, first one disk and ring. First of all, you understood the question.
Yes, sir.
Okay, let's take disk. Disk का moment of inertia with respect to tangential axis. What? And ring. For ring also, moment of inertia with respect to tangential axis. This one we need to find out first of all.
Ring mr square by 2.
Ring, very good. mr square by 2, correct. What about this one? Disk. Disk already I said that mr square by 4 na.
3 by 2 mr
Square
square.
by 4.
What? 3 by 2 na?
Yes.
Okay, correct.
Yes, sir.
Okay, for disk central mr square by 2 plus mr square, correct. Very good. This one,
Yes.
3 by 2 mr square, very good. And now, what is the radius of gyration here? Radius of gyration for disk. Let's take K1, radius of gyration K1. So formula root of I by m na, root of I by m.
Yes.
Here
Yes.
I. What is the moment of inertia I? I is nothing but 3 by 2 mr square by m. So mm cancel. Finally, you can get here 3 by 2 r. What about here? Here radius of gyration K2 equal to I by m root. What is I? Moment of inertia m r square by 2 by m. This one. So here cancel. Finally, you get here 1 by root 2r. Okay, you understood, right? This one.
Yes, sir.
Now he's asking the ratio K1 by
Yes,
K2.
sir.
K1 by 2. K1 here 3 by 2 root r by this one 1 by root 2 r. Here root 2 cancel actually. R also cancel. What you get here from this? Okay, here. Okay. I think already we solved this question also. Okay. 3 by 2 mr square, correct? And this one ring. Okay, same moment of inertia. Ring. Disk. I think disk moment of inertia. Disk. I think we did a mistake for disk. Na? For disk. For disk. What is
Sir,
the
disco only M.
uh, disk central moment of inertia? M r square by 2. Na? What he's asking about tangential axis. Along the plane, he's asking along the plane, tangential axis along the plane.
Yes.
That means
Yes.
already we discussed that also. Like this is the moment of
5
inertia.
by
Very good. So this is the moment of inertia. We can get here
5 by 4 mr square.
5 by 4 mr square. This one 5 by 4 mr square. Now here radius of gyration K1 root of I by m. Cancel here. Can get 5 by 4 r. This one K1. So K1 by K2 now. So that means here I can write here. Can so okay. K1 by K2 equal to what is K1 here? 5 by
5 by 4 root r.
5 by 4 root square root cancel.
R.
Root.
Yes.
This one.
By 1 by 2R.
Okay, just a minute. Okay. 1 by 2 root R. Here, this one will get here. Okay. Now, R cancel. 5 by 4, 4, 2 is there. Okay. 2 and 2 2s are, let's say, 5 by 4, 3 by 2. 5 by 4, 3 by 2. Okay, this is 3 actually, sorry. 3 by 2. 5 by 4 root and 2 by 3 root. So this one you can get here 5 into 2 by 4 into 3 root. 2 1s are 2 2s are. That means 5 by 2 3s are 6. Root of 5 by 6. Okay. I think already we discussed this problem also in class itself. Okay. You understood, right?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. Actually, already we discussed this problem in class. Okay. Next, there are few questions. Okay. Question number 7. Question number 7 and question number 8. This and question number 9. These three are the you can try in home. Okay.
Okay, sir.
Okay.
Yes,
Three
sir.
questions you can try in home.
Okay,
Tomorrow
sir.
we'll discuss this problem. 3 problems. Okay.
Okay, sir.
Any doubts? Anyone
Okay, sir.
has any doubts?
No, sir.
No doubts.
No,
Okay.
sir.
No, sir.
Can I close the session?
Yes.
Okay. Okay. Thank you.